What does it take to build a brain? I'm not talking about a human one. I'm talking about the brain for a humanoid robot like Atlas. Today, we're going to dig into the actual blueprint, the strategy for creating a robotic mind that could literally change the way we work forever. So, here's what we've got on the agenda. We're going to start with the big problem, what's called the automation wall. Then we'll get into the new vision for tearing that wall down. From there, we'll look at the AI blueprint for the robot's brain, figure out what kind of data you need to fuel it, and wrap up by looking at what's next for humanoids once this all comes together. Simple, right? All right, let's get right into it. To really get why humanoids are such a big deal, you first have to understand what's holding back the robots we already have today. Okay, picture this. You're in a modern car factory. You want to automate just one task, let's say bolting on a wheel. Seems simple enough, but the cost to engineer a custom robot for just that one job, you're looking at about $1 million. And get this, it's not just the price tag. It also takes a team of engineers around a full year to design, build, and deploy that one machine. A whole year for one task. So you can see where this is going, right? Even though factories look super automated, this whole approach of building a custom $1 million, year-long solution for every single task, well, it's just not sustainable. The model is totally broken. It just doesn't scale. And the reason it fails comes down to one word: variability. Think about it. A single assembly line might be juggling 5, maybe 10 different car models, each with thousands of different parts. Then you throw in model updates every single year and a complete refresh every 5 years. This constant churn, it creates this hard wall that old-school, rigid automation just can't climb over. Okay, so if these one-trick pony robots are the problem, what's the solution? Well, it means we have to think about automation in a totally different way. The big idea isn't to build 1,000 different robots for 1,000 different jobs. No. The vision is to build one kind of robot, a generalist, that you can teach to do thousands of jobs. Kind of like how a human worker can learn to do a bunch of different things. But, and this is a big but, having a general-purpose body is only half the battle. I mean, you can build the most incredible athletic robot hardware imaginable, but if you don't have a general-purpose brain to run it, you're right back where you started. So that's the multi-billion-dollar question, right? How in the world do you build a brain that can learn thousands of different physical jobs instead of just being hard-coded for one? Well, it comes down to a huge shift in thinking. The old way was all about programming. Engineers sitting there writing line after line of code for every single motion. It's brittle, it doesn't scale. The new way is all about teaching. You have an expert literally show the robot how to do a task, and the robot learns from that demonstration. All that knowledge gets stored in a neural network, so it's not just learning a task, it's building a library of experience. Honestly, the best way to think about it is this. It's like building ChatGPT, but for physical movement. You know how large language models are trained on the entire internet of text? The goal here is the same, but instead of text, you're building a massive foundational model trained on the entire internet of human physical action. And this whole process really breaks down into 2 key steps. First, there's pre-training. This is where you build that huge foundational model. You give it a kind of physical common sense about how the world works. That way, when it sees a brand new task, it's not starting from scratch. It has a pretty good first guess. Then you move to post-training. This is where you fine-tune the model for a specific job. An expert might spend just a day or so showing the robot the ropes, and that's it. Okay, but any AI model is only as good as the data it's trained on, right? So if we're building this ChatGPT for movement, where on earth do you find the data? Where is this internet of physical action that you can feed the machine? Well, the strategy is pretty clever. It relies on what they call 3 main data swim lanes, and each one is super important. First up, you've got teleoperation. This is exactly what it sounds like. A human expert straps on a VR headset and directly controls the robot, almost like a puppet. The data you get from this is amazing. It's what they call ground truth, because it's the robot's own body performing the actions. The big downside, it's really hard to scale. It's slow, and honestly, the human operator might not even be doing the task in the most efficient way. Swim lane number 2 is reinforcement learning, or RL. This is where an AI learns by just trying things out, over and over again, but inside a simulation. And this is where you get scale. You can run thousands of these simulations at the same time, 24/7. What's cool is the AI can actually discover superhuman ways to do things, movements that are way more efficient than a person. The big hurdle, though, is the sim-to-real gap. You have to make sure what the robot learns in the virtual world actually works in the real one. And finally, we have the third lane, which is honestly the biggest moonshot of them all: human observation. This is the idea of training the AI by just having it watch us. We're talking YouTube videos of people doing, well, everything: assembling furniture, working in factories, you name it. The potential for scale here is just off the charts, and it's the best way to soak up that broad human common sense. But it's also a massive, long-term research project. So when you look at it all together, you see the path forward. Teleoperation is great for getting high-quality data right now, but it won't get you to the finish line. The real key to building a generalist robot brain, that's going to come from reinforcement learning and human observation. Those are the only two methods that can generate data on the insane scale we're talking about. All right, so we've got the blueprint for the brain. But what does the whole package, the robot itself, need to actually be, successful out in the real world? What does it have to deliver to really change the game? Well, it really comes down to 5 main things. 1, the hardware has to be genuinely general purpose. 2, you need to be able to retask it for a new job in a matter of days, not months or years. 3, you have to be able to interact with it naturally, just by talking to it or showing it what to do. And finally, 4 and 5 are the big ones. It absolutely has to be safe to work around people, and it has to be rock-solid reliable. And look, the long-term vision here is huge, right? We're talking everything from package delivery right to your door to robots helping out in our homes. But the focus right now is laser sharp. Start with manufacturing, crack that incredibly difficult nut first, and then build out from there. So that kind of leaves us with one final thought to chew on. The blueprint for a general-purpose robot brain, it exists. We just walked through it. So the question is no longer if we can build it. The real question is, what happens when we do? How is our world going to change when this brain is fully built?